All right, and here we go. We're going to continue working with our table of values, but now what you're going to see is that we're going to look at some different behaviors, and that behavior, all right, will hopefully help us identify an absolute value function from our table. So when you look at our standards that we're going to cover in this particular lesson, we have standard 1.2, I can identify an absolute value function from a table of values. 2.2, I can identify the rate of change for an absolute value from a table of values. And 3.2, I can find missing values in a table or extend that table using my knowledge of absolute value. So the good news is the questions aren't changing. So we're going to be asking you the same types of questions we've been asking you as we covered linear function. What's going to change, right, is now you have linear and absolute value. So you're going to have to look for those little particular details, all right, that distinguish between linear and absolute value. All right, so to get us started, we have an opener here. All right, so I'm going to read this, and then what I want you to do is once I'm finished reading this is pause the video, all right, attempt the opener here, and then we'll go from there. All right, so due to a drought, the canal from a reservoir is open, so the reservoir is lowered by 15 feet for 6 days to meet the irrigation needs of farmers. After this, the canal is closed and water is directed from a river to raise the water level back to its original level at the same 15 feet change per day. So here's what I want you to do is pause the video and go through parts 1, 2, and 3 of our opener here. Flip the video back on and we will discuss it and see how you did. All right, so a lot of times what we want to do is just draw a sketch of the situation, right, to give that visual, right? So we've kind of seen the picture of our functions, and so we have a picture that might help indicate what type of function we're working with. So if we think about it, right, so if I look at just creating a all right, a little quick XY table, we know, right, that the original level, all right, of the lake or the reservoir is 500 feet. And so what we know is that it is lowered by 15 feet for 6 days. And that seems like linear, right? That's a constant rate of change, right? So it's lowered, right, by 15 feet per day until day 6. And I'm just going to put day 6 right there. So that reservoir is going down, 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 15, 15, 15, 15 till day 6, right? And then after this, they close the canal and then they're refilling the reservoir, right? And so we know then it goes back up, right, at the same 15 feet per day until it gets back to that original, right? And then we get back to that original 500 feet. And so what we can see is by sketching this situation, we can see that we get that V graph, right? And we know for some of our earlier things that we did in this class, right, that if the graph looks like a V, whether it's a V that opens up or a V that opens down, we know that's an absolute value function. So that's one of the powerful things that we want to do by drawing the situation, all right, is creating that visual representation, all right, and then that keys a lot of the things that we know about functions. Now, if we translate that to what we've been working on right now, okay, all right, so let's think about time and let's think about our height, right, of the water. On time 0, we know it's at 500 feet, right? And then day 1, it went down 15 feet. So now I'm at 485. And then day 2, it goes down another, and I'm at 15 feet, and I'm at 470. Day 3, it goes down another 15 feet. So now I'm at 455. And then day 4, it goes down another 15 feet, and I'm at 440. Day 5, it's down to 425. And then day 6, it goes down another 15, and I'm at 410. And this is now, if we think about our rates of change, right, and what we've talked about with linears, right, we can see that all my x's right here, right, are going up by 1. And then all my y's are changing by going down 15. So we see we have that constant rate of change. 15 to 1, I'm sorry, negative 15 to 1, negative 15 to 1, negative 15 to 1, right? So it looks linear. But here's why it becomes absolute values. What happens right here, we hit this turning point, all right, or the vertex right here, and we change direction. So that's the big difference. That's the big indicator between absolute value, all right, and linear. We have a constant rate of change, but then it changes direction and gives us the opposite, all right, rate of change. And so notice now at day 7, it starts filling back up, right? And it's going to go back up by 15. So now I get back to 425. And then day 8, it's going to be back up to 440. And day 9, it's going to be back up to 455. And I can see that I'm adding 1, but now we get that opposite rate of change, right? It's still a constant, but it's a constant in the other direction, all right, around this turning point here, okay? And so now what type of function do we think this is? We think it's absolute value. And I've already mentioned a couple of reasons why, right? So constant rate of change, all right, in both directions, and that turning point. All right. So hopefully you see like, okay, this has some characteristics that are similar to linear, right? The constant rate of change. But it's really that turning point where we get both rates of change in opposite directions. That is a key characteristic. So now let's take what we just talked about right here, all right, and add some notes here. So key characteristics of an absolute value function. All right, so one key characteristic, right, and I'm going to put this right here, is that it has a turning point, all right, or vertex. Okay, that is a very key piece, right? So we have that turning point. And then another key characteristic, if we go back up here, right, all right, key characteristic is that we have a constant rate of change in both directions. All right, and I'm going to put this, we're going to have plus or minus, right, whatever our rate of change is, right? So like if we were doing this, we'd say it has a constant rate of change of plus or minus 15. All right. Some key characteristics. Another one is symmetry around the turning point. And what I mean by that is if we look, right, one above is 420, or excuse me, one below is 425, one above is 425, right? Two below is 440, two above is 440. Three below is 455, right? So once we find this turning point, right, we can see that there's symmetry, right? So 425, 440, 455, 420, 440, 455, 470, 485, 500, right? And that really helps us when we're filling out our tables, right? Because if we can find that turning point, we know about symmetry, we can start matching values above and below our turning point. And then we have a V-shaped graph, right? So it's going to look like that, or it's going to look like that. So those are the key characteristics that we want to look for and help us recognize that we're working with an absolute value function. All right, so let's go ahead and do a couple of examples together. All right, so let's jump over here, all right, to page 2 of your notes here. Let's look at problem 1. All right, and once again, notice, all right, rate of change, right? Unit rate, function. So same questions we've been asking, but now we have to be aware, okay, that we may have more than one function, right? And we have to really analyze what we see. So one of the first things that we want you to do, all right, is look at your table and see if there's a turning point. Because here's what we know from our exploration activity at the start of this unit. We have two functions that have a turning point, absolute value or quadratic. So if we find a turning point, we know it either has to be absolute value or quadratic. If we don't see a turning point, right, we have to do maybe a little bit more work to see which particular function is, but we can cut our choices in half if we see a turning point. So when I look at problem 1 here, right, and what we know with a turning point is that it's got to go down and then back up, right, or it's got to go up and back down, right, so we get some kind of change. And so notice I'm going 21, 18, 15, 12, and then notice right here, I go 15, 18, so I can see that it changed direction, right? I start seeing repeating values. I see that symmetry. So my turning point here, and I want everybody to circle that, is 9, 12. So right now, because it has a turning point, I know my choices are either absolute value or quadratic. And the way we're going to determine the difference in those two things, right, is looking at the rates of change. So now let's go through the same process we did with linear. Let's look at our changes of x's and our changes of y's and look at the rate of change. Now, notice when I look at my x column here, everything is going up by 1. So up by 1. All right, now let's look at our y column. So 21 to 18, I go down 3. 18 to 15, I go down 3. 15 to 12, I go down 3. And then notice what happens now. We change direction, right? So when I go from 12 to 15, I now go back up 3. And then 15 to 18, I go up 3. 18 to 21, I go up 3. 21 to 24, I go up 3. All right. So now when I look at my rate of change, I have a constant, but now it's a plus or minus 3 to 1. All right, so we have the down 3, up 3. All right, we have that turn, we have a turning point, we have that constant rate of change, and that tells me that this has to be an absolute value function. And then my unit rate of change right here is that 3 to 1, right? Okay, so we saw that. All right, so hopefully you see the difference between absolute value and linear right here, right? Okay, so we get that constant rate in both directions. All right, let's look at number 2. Let's look at number 2 here. All right, so once again, I want you to pause the video and I want you to see if you see a turning point. And it could be a yes and it could be a no. All right, and if you do see a turning point, I want you to circle it. All right, let's see how you did. So when I look at this, I see I'm going up to 28 and then I start going down again. So I see I have a turning point right here. And so what I know right now is I'm either dealing with absolute value or quadratic. Now, once again, when we look at our change in x here, when I look at all my x's, all of these guys are going up by 1. And now we look at our y's. How are my y's changing? I go up by 6. 10 to 16 is up by 6 again. And then I go up 6 again. 22 to 28, I go up 6 again. 28 to 22, I go down 6. 22 to 16, I go down 6. 16 to 10, I go down 6. So we can see that we get that constant rate of change, right? 6 to 1, 6 to 1, 6 to 1, 6 to 1. And now we go in the opposite direction. Negative 6 to 1, negative 6 to 1. So we have a constant of plus or minus 6 to 1. And once again, we're dealing with unit rates here because our change in x is 1 for all these. So our unit rate is 6 to 1. So we have a constant rate of change in both directions with a turning point. That means our function is absolute value. All right, so there you go for, all right, problem 2. All right, now let's jump down. We'll skip problem 3 for now, but let's skip down to number 4 here. All right, and talk about how we can use this idea to now fill in missing values in our table. So once again, when I look at my table, right, I have to kind of know what function it is because I have to know what type of pattern to use to fill in, all right, our values here. So let's start looking at what's happening in the x column. All right, so notice these are all going up by 1. Now let's see what's happening here. Oh, 5 to 2.5, I go down 2.5. 2.5 to 0, I go down 2.5. 0 to negative 2.5, I go down 2.5. So right now it looks like it's linear, right? Negative 2.5 to 1, negative 2.5 to 1, negative 2.5 to 1, right? It looks like it's constant. And now I'm like, oh, I've got to jump, I've got to skip. But notice what I see here. I see negative 2.5 again. Well, if it's linear, it would just have to keep going down, right? And so that what that means is that if I see another value that I've already had previously in the table, it means it had to turn. All right, so think about this. Like if I go down another 2.5 here, all right, I would get to negative 5 here. And then notice what happens. Now when I go from negative 5 to negative 2.5, I add 2.5. So I've now changed directions. And hopefully now you're like, oh, now I can see that symmetry, right? There's my turning point right here. And now things start to match, right? Negative 2.5, negative 2.5. I have a 2.5 here and I have a 2.5 here. So then if I use symmetry, I can see that, oh, 0 needs to be right here. And if I continue my pattern, if I add 2.5, negative 2.5 or 2.5, that gets me to 0. And if I add 2.5 again, that gets me to 2.5. So I can use rates of change, I can use symmetry, okay, to help me identify that. So what's my rate of change? My constant, and I get that both directions, so negative 2.5 to 1. The unit rate is 2.5 to 1. And we have that constant both directions, and it means it's absolute value. All right, let's do one more together. Let's do number 5 together. Now, once again, when we start looking at what's happening here, all right, I look at my x's here. All right, I look at my x's. I can see that they're all going up by 2. All right, all going up by 2. All right, now I want you to take a look at your y's, right? Does anything stand out about our y's here? Do you see anything in this table? Maybe pause the video, look it over, and see if you see a turning point. All right. So hopefully, when I look here, I'm like, and what happens if you look for that symmetry, right? I can see a 7 and a 7 here. It's like it had to change direction here. So notice when I go from 7 to 6, I go down 1, right? And when I go from 6 to 7, I go up 1. If I jump down here from 9 to 10, it goes up 1. So it looks like, right, I have that absolute value graph, right? So add 1. So notice if I, and it's all constant here. So every time x goes up by 2, in this direction, I'm going to add 1. So I'm going to add 1 right here, and notice I get to 8. And if I add 1 here, I get to 9. If I add 1, I get to 10. And if I add 1 more, I get to 11. And then now if I go this way, I must have subtracted 1 here to get to 7. And I can use symmetry to help, right? So 7, 8, 9, 10. So it should be 7, 8, and then 9, 10, 11 if I kept going in that direction. And if I keep the pattern here, 8 minus 1 is 7. So my rate of change, right? So I have a constant of plus or minus, all right, 1 over 2. All right. Now my unit rate, if I take this and divide this out, this is going to be 1/2, right? So this is 0.5 to 1. So plus or minus, and I should put plus or minus here. All right, on all my unit rates here since we're doing that. Plus or minus, and this would be 0.5 to 1. All right. And then once again, that means it's an absolute value. All right, so that wraps up our work for absolute value today. We'll pick up with this lesson in class next time. All right, I'll see you then. Have those questions ready for me if you have any.